In section 4.5, we learned to convert from fraction notation to decimal notation, and you find it fairly simple and easy to do. One way to do it is to find the decimal notation by multiplying by 1. For example, when we have the fraction of 4/5, excuse me, we can multiply 4/5 times 1, or 4/5 times 20 divided by 20, and 4 times 20 is 80, and 5 times 20 is 100, and 80 divided by 100, remember we move the decimal 2 places to the left, that's 0.8. Similarly, in example number 2, 9/20, we divide 9 by 20 multiplied by 5 divided by 5. That's of course equal to 1. And 9 times 5 is 45. And 20 times 5 is 100. And 45 100ths, we move the decimal 2 places to the left. It's 0.45. Similarly here, 11/40, we multiply that by 25 divided by 25. So in the denominator we get 1000. And 11 times 25 is 275. So 275,000. We have 3 zeros in the denominator. So we move the decimal 3 places to the left. This will then be 0.275. In exercise 4, we can multiply 2/5 by 20 divided by 20. Then we have 2 times 20 is 40, and 5 times 20 is 100. And so now we move the decimal 2 places to the left, and this is then equal to 0.40 or 0.4. 0.4. 3/8. Let's do it in 2 ways. One way we can multiply the numerator and denominator by 125. And so we have 3 times 125 is 375, and 8 times 125 is 1000. So here we have 3 zeros in the denominator. We move the decimal 3 places to the left, and this is then equal to 0.375. Another way to do number 5 is to simply divide 8 into 3. So when we divide 8 into 3, eight into 3 is 0 point, and then 30. 8 goes into 33 times, and 3 times 8 is 24. So we have 6, and the next 0 would be 60. 8 divided into 60 is 7. 7 times 8 is 56. So then there's a 4, difference of 4. Another 0 makes it 40. 8 into 40 is 5. So the quotient is 0.375, regardless how we arrive at the answer. So we can directly divide 8 into 3, or we can do it this way by multiplying by 1. in this case 125 divided by 125, to get 1000 in the denominator. Let's look at the example 1 divided by 6. So 1 divided by 6 is obviously 1 divided by 6. Or if we divide 6 into 1, first of all we get 0 and then 10. 6 goes into 10 one time. And then 10 minus 6 is 4. And then bring down to 0. 6 into 40 is 6 times. And then 6 times 6 is 36. Again, 40 minus 6 is 40. And so the pattern repeats. And so 1 divided by 6 is equal to 0.1666 ... And so what we do often to replace the repeating part, we replace it with a bar. This tells everyone that the pattern of the 6 will continue. The pattern is sometimes just one single digit, like in this case the 6. It could be 2 or 3 or more digits that have a repeating pattern. And we look at some of these examples later on. So this is an important notation that you understand what this means. It means the 6 keeps repeating indefinitely. In a similar way, we can express the fraction of 2/3. So we divide 3 into 2, which is 0 point, and then 20, 3 goes into 26 times, and 6 times 3 is 18. We subtract, it gives us a 2 and then 0. 3 goes into 26 times. So we see that this pattern will continue on and on and on. So we write this as 2 divided by 3 is equal to 0.6 with a bar. Exercise number 8 is very similar. We divide 11 into 5. So when we divide 11 into 5, it's first of all 0. And then 50, 11 goes to 5 4 times. So that's 44. And then the difference would be 6. And the next, we have a 0. 11 into 60 is 5 times. And 5 times 11 is 55. Then we have a 5 here and a 0 here. And so now we're starting all over, because now 11 goes into 54 times. And so we have 44 here. We subtract, that gives us a 6, and the 60 gives us another 5. And so you can see the pattern that's developing here. And so therefore we say this fraction is equal to 0.45. And so in this case the bar goes over the 4 and the 5, because the 4 and the 5 keep repeating. Let's look at number 9, where we divide 11 into 12. So we divide 11 into 12, which is 1. And 1 times 11 is 11, so the difference is 1. Now comes the decimal. And so 11 to 10 is 0. And then 11 into 100 is 9. 9 times 11 is 99. So now we have 1, and we get a 0, and 11 into 10 is 0. So next 0, we have 100. 11 into 100 is 9. And we see the pattern, that the repeating pattern is 0909. So in other words, this is equal to 1.09 with a pattern of 09 repeating indefinitely. So this may be new notation for you, but it's important one. It's important to understand what it means when you see it. And it's important that you can express this yourself, similar to what I showed you here, how to compute these decimal fractions, decimal notation. Next, we'll investigate rounding and problem solving, and here are some examples to round each of the following to the nearest tenths, 100ths, and thousandths. So here's number 9. The number is 0.83 with a bar over the 3. In other words, the 3 keeps repeating. So the nearest tenth, of course, is 8. And since it's followed by a number less than 5, we simply round it down, and it's equal to 0.8. The nearest 100ths would be 0.83, and since that's followed by 3, we round down, and it becomes 0.83. And to the nearest 1000ths, it's 0.833 followed by 3, so we round down, and it becomes 0.833. Here, when we have 0.09 with a repeating pattern of 090909, so the nearest tenth would be here. Since the 0 is followed by 9, this becomes a 1, and this becomes 0.1. To the nearest 100th, so it would be here at the 9. The 9 is followed by 0, so we round down to 0.09. To the nearest 1000ths, 10 100,000 would be the 0 here, but the 0 is followed by 9, so we round up, make this a 1. So that's why this is 0.091. So you may want to give that some thought and see if it makes sense to you, that you can repeat that yourself. Now the next one is a little bit trickier because here the repeating pattern extends over 6 digits. Nonetheless, we know what it means. These 6 digits repeat, and they're repeated twice here. The pattern is repeated twice. So, but still, to the nearest tenth, there would be to the 7 here. And since the 7 is followed by 1, we simply round down to 0.7. To the nearest 100ths, that would be the 1. The 1 is followed by 4, so we round down, it becomes 0.71. And to the nearest thousands, there would be at the 2, but the 2 is followed by an 8. It would be 4. Since the 4 is followed by 2, we round down. It becomes 0.714. And so here we're asked to round to the nearest tenths, hundreds, and thousands. So again, the important thing to realize is what this means. This equals 0.66666. So to the nearest tenths, we can just continue here. That would be 6 here, and followed by 6, so it becomes 0.7. And to the nearest 100ths, that would be here, that would be the tenths one, that would be the hundredths right here. Since that's followed by a 6, we round it up to 0.67. And to the thousandths would be this digit here. And since it's followed by a 6, this 6 becomes a 7. 0.667. So again, to round to the nearest tenth, here's a tenth, and it's followed by 6, we round it up to 0.7. For the nearest hundreds, this would be the hundredths position, followed by 6, we round it up to 7, so it's 0.67. The nearest thousands, that's this 6 here, followed by 6. That means the 6 is rounded up to 7 and becomes 0.667. And for number 12, this means 0.808080, etc. So to the nearest tenth, there would be 0.8 followed by 0. So we just round it down to 0.8. Then to the nearest 100, so it would be this 0 here. Since it's followed by an 8, we round it up to 1. So this is then 0.81. And the nearest thousands would be this 8 here, followed by 0, so we round it down. And then it's 0.808. And number 13, this means 6.245, etc. So for nearest tenths, that would be the tenth, and since it's followed by 4, we round it down to 6.2. The nearest hundred, since the 4 is followed by 5, it becomes 6.25. And then for the thousands, that would be the 5, and since the 5 is followed by 2, we round down to 6.245. So here's a little application problem, coin tossing. A coin is tossed 51 times, it lands heads 26 times. Find the ratio of heads to tosses and convert it to decimal notation, rounded to the nearest thousands. So what that means is that it lands heads 26 times out of 51 tosses. So that is the ratio of heads to tosses. So we're supposed to convert that to decimal notation, rounded to the nearest thousands. What does that mean? We divide 51 into 26. So that's 0. Point, and then 260, 51 goes into 260, so then 51 into 260 is 5 times, that's 255, subtract gives us a 5, makes it 50, and 51 to 50 goes 0. Now for the next 0, 51 to 500 is 9 times. And 9 times 51 is 459. Subtract, that's 41. So now 0, 410. 51 into 410 is 8. And so 51 times 408. 8 times 51 is 408. This is 2. And so we don't need to go any further here because the nearest thousands. So when we look at, well, we can put a 0 here. So when we look at the number, it's a quotient 0.50980. And of course there are other digits too, but leaving it at this because we don't need more of the thousands. So the 1,000 is the 9, and so then that's followed by an 8 we round this up to a 10, so it becomes 0.510. So round it. In number 15, we're asked to compute the gas mileage. A car traveled 380 miles on 15.7 gallons of gasoline. Find the gasoline mileage and convert the ratio to decimal notation, rounded to the nearest tenth. So miles per gallon is exactly what it means. So it's miles per gallon. So we know we have 380 miles divided by 15.7 gallons. So when we divide 15.7 into 380, remember how that is? We multiply by numerator and denominator by 10. So this then becomes 157 divided into 3,800. So we multiply numerator and denominator by 10 to get a whole number in the denominator. So now we can divide, and 157 into 380 is 2 times. So then 2 times 157 is 314. So the difference here then is 66. Bring down the 0. And that's 157 to 660 is 4 times. And so it's 4 times 157 is 628. So then we have 32 as a difference. And then 320, 157 into 320 is 2 times. And remember, here's a decimal now. And 2 times 157 is 314. We subtract, it's 6. And 157 to 60 is 0. And so that's really as far as we need to do the calculations. Because 24.20 to the nearest tenth, since the 2 is followed by 0, we just round down. So then the answer is 24.2. In other words, it's 24.2 miles per gallon is the mileage. Miles per gallon. So here's the ratio, or here's the quotient rather, 24.2. So these are just some very simple applications of some of the basics that we've learned here. In exercise number 16, we are supposed to compute the port volume. And so here we're referring to the data for the various ports and the volume of cargo in millions of tons. So there are 6 ports listed here. And find the average volume for the top 3 ports, and then for the 4th through the 6th ports. Round the answers to the nearest tenths. Remember how we find the averages? We add the numbers and divide by the number of addends. So for the top 3, we have 267.4 plus 234.3 plus 126.2, divide by 3 because there are 3 addends. So that's equal to 627.9 divided by 3, and that is equal to 209.3 million tons. So that's for the top three. And then for ports 4 through 6, ports 4 through 6, we add up these three numbers, 87.3 plus 85.0 plus 84.9 divided by 3, and that's equal to 257.2 divided by 3, and that's equal to 85.733, so it's equal to 85.73 with a bar. But since we only need to answer to round to the nearest tens, the answer is simply 85.7, because since the 7 is followed by 3, we round down, so 85.7 million tons for ports 4 through 6. Now we're going to look at the combination of fraction notation and decimal notation together. So in certain kinds of calculations, fraction notation and decimal notation occur together. In such cases, there are at least three ways in which we might proceed. So the basic exercise is to multiply 3/4 times 0.62. So it's 3/4 times 0.62. Well, 3/4 is 0.75, and multiplying that by 0.62 will give us 0.465. That's one way. Another one is to say 3/4 times 0.62 is 3/4 times 62 divided by 100. And 3 times 62 is 186, and 4 times 100 is 400, and 186 divided by 400 is 0.465. That's the second way. And method 3, 3/4 times 0.62 is 3/4 times 0.62 divided by 1. And now we take the product of the numerators. 3 times 0.62 is 1.86, and 4 times 1 is 4, and 1.86 divided by 4 is 0.465. Of course, the results are always the same, which is what you would expect. But here you have three ways to multiply a fraction times a decimal. For number 18, let's use method 3. There are different, of course, you can use any one of these methods, but let's use method number 3. In other words, this then will be 1 divided by 3 times 0.384 divided by 1 plus 5 divided by 8 times 0.6784 divided by 1, which is equal to 1 times 0.384 is 0.384 divided by 3, plus 5 times 0.684, that's equal to 3.392 divided by 8 times 1, or divided by 8, and that's equal to 1 divided by 3, that's 0.128 plus 0. would be 4, 2, and this 3 would be 4. So then the sum of these two is equal to 0.552. So that's the answer here, 0.552. For number 19, we use the previous method, number 3, to multiply 56 times 0.864 divided by 1 plus 14.3 divided by 1. And remember, we divide by a fraction by multiplying by the reciprocal of the fraction, so times 5/8. So then 5 times 0.864 is equal to 4.32 divided by 6 times 1, or 6, plus 5 times 14.3 is 71.5, 71.5 divided by 1 times 8, or 8, and 4.32 divided by 6 is equal to 0.72, and 71.5 divided by 8 is equal to 8.9, then a 3, and then a 7, and then a 5. Okay, so we add these two numbers, and that is equal to 9.6575. 9.6575. So that's how you can make sense out of a combination of fractions and decimals. It's probably easier to convert everything to decimals. This is the end of section 4.5.